Okay, everybody, today we talked about inverse functions. So, of course, all the work's here, but I'll go with it. We'll go through this. So, first of all, we started with a graph. Y equals 2/3 x minus 6. We graphed it, y-intercept of -6, slope up 2 over 3, upper 2 over 3. So then, easy, that was the graph. But now, every graph has an inverse. What is an inverse? Well, an inverse is like its opposite. So how do you do the opposite of a graph? Well, the way you do the opposite of a graph is just switch the x and the y's. So it becomes a y, then an x. So we said, okay, well, if we want the inverse of this graph, we took all of these points, 0, 6, and made it -6, 0. 3, -4, we made it -3, 4, 6, -2, -2, 6. So I just switched the x and y. And then I graphed those points, -6, 0, -4, 3, -2, 6, and I graphed it. So this is the graph, this is the inverse graph of our original graph, okay? Now to find the equation of the inverse, well, same thing, I switched my x and y becomes x, and x becomes y. I got x equals 2/3 y minus 6, and then I need to solve, so plus 6, right? And then I multiply by 3, and then I divide by 2, and then I wind up with y equals 3/2 x plus 9. Now, it is its inverse. We wrote this symbol here. F, this -1 means that inverse. F inverse of x is equal to 3/2 x plus 9. Okay, that's the inverse equation. That's the equation of this line, all right? So then we notice a couple of things, that since we switch x and y's, this y-intercept is now an x-intercept. This x-intercept is now the y-intercept. And we also saw that the two graphs are always going to be a reflection over the line. You can see it reflect. They are always a reflection of each other over the line y equals x. Okay? All right. So then we took a more deeper look at this, and we looked at graphing y equals x squared minus 4. And that's a parabola, and it looks like this. Okay? We found all the important points of my parabola. We wrote them down. Okay? Found all the points of my parabola. We wrote them down. And then we switched them. 5, -3, 0, -2, -3, -1, -4, 0, so forth and so on. And then we graphed those points. But when we graphed these points, we realized, and I believe it was Sully that said, wait a minute, if I graph this line, it isn't a function. He said, you're right, so there's a problem. This graph does not have a function. It does not have an inverse because its inverse is not a function. So we said it doesn't have it does not have an inverse because it does not pass the vertical line test. Sorry, my bad. So then I said, well, I want it to have an inverse, so I want to get rid of this back half of the graph so that it has a function. So I got rid of the back half of the graph by changing its domain. So let's change the domain to x is greater than or equal to 0, so I only see the positive part of this graph. When I do that, then when I switch the points, I get rid of all of these points, and I only have the top part of the graph, okay? So now it has an inverse graph. Well, what's the equation? Well, we solve for it. Y equals x squared minus 4. We switch x and y's, remember? Switch x and y's for the inverse. I added 4, and I took the square root. So the inverse is, F inverse is the square root of x plus 4. Now we saw the domain change becomes the range of the other. We saw the range of the original becomes the domain of the other. And then finally, the last inverse graph we did was an exponential. Okay, and on this exponential, we graphed all of the points for the exponential. Again, we switched the points, and then we graphed its inverse. Okay, and then we made the equation. Well, x equals, switch them around, x and y, switch them around. X equals 2 to the y is not a very good answer, and I introduced the concept of logs, which we're going to talk about more about logarithms. So exponentials, inverses are logarithms, but I'm going to talk more about that another day. Okay, so that's all I have. And home.